I want to talk about Gibbs sampling and metropolis hasting algorithm that uses uniform proposal distribution. Before we talk about that, make sure you understand block log distribution and log probability of joint assignment. I've actually created short videos related to these. In case you have not watched, I highly recommend you go and look at them. So basically, just for a quick recap, log probability of joint assignment. Basically, you have a distribution defined by a set of factors f, and you have an assignment for each of those variables in those factors in the distribution. So, for example, ID in the probability of ID GSL, you have I0, D0, S0, G1, L1, and then you're computing what's the probability of that. So that's what this joint assignment, probability of joint assignment is. Because it's a log space, these are all added. So here, this one is actually the Gibbs transition. This Gibbs sampling is fairly easy, assuming you've already done the block log distribution. All you have to do is, let's see, you have to use this function called rand sample, which is right here. Let's see what it takes. So it takes set of variables like a matrix, like 1, 2, or and then n is so n values sampled at random. So returns a set of n values sampled at random from the integers 1 through v with replacement using distribution. So this distribution here is your block log distribution with replacement. For now, just assume it is true. In case you did particles filters, I think Professor Sebastian Thurn has actually taught a class on that, and you will understand what that with replacement is. But for now, you can just assume that's true. And this is number of variables, set of how many values you're sampling. In this case, it will be 1 for our Gibbs sampling. And this wheel, it's actually a matrix, like you can pass variable 1 just in one square brackets, or you can pass square brackets 1 space 2 square brackets close. Or for example, let's say you have just two integers 15 and 16, and you want to sample based on the weights or based on this distribution that's passed here. You can just pass square brackets 15 space 16 square brackets close. So that's all it is doing, is just randomly sampling and giving you based on these weight increments of this distribution. It's giving out the picking up the values in this V matrix and returning. Actually, if you take Octave and start playing with it, you'll understand. So once we understand that, so all you have to really do is so you're going through one variable at a time, the g dot names. So I equals 1 through g dot names for each variable. Well, all you have to do is call this guy right here. You pass that variable, then you know how here they said you should call the function exactly once, and it should be the only random function you call. So you just call it once, and you're only getting, you want to only sample one value at a time, and then replacement true, and you pass your distribution, which is they're saying you have to use the block log distribution, and make sure that the block log distribution is in log space, so you want to remember that, and probably want to exponentiate that. Okay, so that's all there is to it. So once you do that, you return the so for that way, so what do you, so once you call this guy, it will sample one of the assignments, right? If A takes values 1, so the coordinate of the variables is say D, so 1 through D. It will sample this RA&D sample will basically sample one of those values from 1 to D, and then for the variable that the current variable I, you have to set the value in the A that's given to you. Okay. The next thing is the next thing I really want to talk is MH uniform. So this is basically the Metropolis Hastings transition function that utilizes uniform proposal distribution. So let's go back to our very important slide, the most important slide of this whole sampling techniques that we learned, right? We said acceptance probability of going from state x to x prime, current state to new state, is min of 1 comma pi of pi of new state x prime to times q is remember that's the proposal distribution, q of x prime to x, that is going from current state to the new state to current state, divided by pi of current state times q of current state to new state. So now remember, so how do we actually implement this in our code, right? That's what we are supposed to do, because that's what they're asking, right? Compute the acceptance probability. And at first it may seem really strange, all these equations and this pi of x especially. Remember when you guys, when they taught us this in the class, yeah, this is how we got these 3 equations, and we had this constraint of this, all this sum to 1, and that's how we arrived at pi of x1, pi of x2, pi of x3. If you're wondering what happened to all of this and how are we going to do all of this here, well, wait a minute. So what is pi of x? It's just a distribution, right? Correct? So pi of x is just a distribution, and you have this AGF, and you have this good old log probability of joint assignment, which you can use, and just compute the your pi of x. So that's I think that's all there is to it, really. So it is this mapping in your mind between this pi of x and this probability of joint assignment. Once you understand that, from here it becomes pretty easy. This is all just purely, just from, if you understand the fact that log probability of joint assignment is really what there is is really your pi of, where is that? This pi of x right here, right? Right here, this pi of x prime, and pi of x is nothing but your log of probability of joint assignment. That's what you, so pi of x prime will be, the x prime will have the proposed values, and x will have the current a values. Okay, so that's your a proposed, and then yeah, so that's your a proposed, and obviously you have your a, which is your current. So I hope you understand that. So if you take this and you map to, so if you're able to understand this guy right here, this pi of x prime or this pi of x is nothing but just computing probability of joint assignments. Of course, because this is in log space, this is log probability of joint assignment. The entire rest of PF5 is pretty easy. It's just a matter of understanding log of AB is log A plus log B, and log of A by B is log A minus log B. Okay, I think one of the biggest hurdle, or at least in my case, the first time I saw this, I remember when we went through the class, they talked about how to get these pi of x1, x2, x3 like here, and I was trying to make connection between this and, oh god, how am I going to calculate this? But, well, if you just treat pi of x as just a distribution, and which is what it is anyway, and then you have this AGF and you have this log probability of joint assignment, you should be able to compute pi of x and pi of x prime. X prime will use a proposal, and x will use, pi of x will use a. Okay, and then last thing here is because this is uniform proposal distribution, what that means, the proposal of going from x to x prime is same as the probability of going from x prime to x prime. So both this q of x prime to x divided by q of x to x prime will get cancelled out, and all you will be left with is min of 1 comma pi of x prime divided by pi of x. That's all there is to it. Good luck and thank you.